relations and functions. A relation is defined simply as a set of ordered pairs. So remember, an ordered pair is an x comma y. So when I take two or more of them and group them together into a set, then that set is called a relation. So you can see here that I have a table of values showing the age and then the measured height of some giraffes. Each of these pairings becomes an ordered pair. So what you see over here to the right-hand side, this would be defined as a relation. When we are dealing with a relation, the domain of the relation is the set of all the x coordinates. So if I make a list of all the x's or all of the first parts of the ordered pairs, that's called the domain. If I make a list of all the y coordinates or the second part of each ordered pair, that is called the range. So you should be able to list the domain or list the range of a function or relation. So if we look at this first example, it is asking us here to find the domain and the range of the relation that's shown. And you will see that this one is listed so that your table actually has these labeled as domain and range. But this left side column is where you would find your x's, where that's labeled domain, and the right side column is where you would find your y values. That's why it's labeled range. When we are listing domain and range, a couple of things to know. Typically, we list the values from least to greatest, and it's a set of values. So in math, when we're listing a set of values, we use this symbol to indicate the set, kind of a curly bracket. So we're going to list the x values, the domain values from least to greatest, and then also we do not repeat values. So it doesn't matter how many times it shows up. If it's there, it gets to be on the list one single time. So if I look in the left side column, the smallest value that I see is -2, and then we have -1, and then we have 4. So that list would be my domain. If I want to look at range, then I'm looking at making a list very similar to above, but this time I'm making a list of all of the y values. Again, I'm going to list them from least to greatest, and I'm not going to repeat any values. So I have -2, 1, and 3. So this is domain and range. So in this example, we have a list of ordered pairs. So we are given a list here of ordered pairs, so it's not listed in a table. But the idea here of finding domain and range is still the same. So the domain, again, is all of the x values. And like I said, when we define domain, the x values are the first part of the ordered pair. So when I list the domain, I'm still going to list it in the curly brackets because it's a set of numbers. I want to list them from least to greatest. So the smallest value that I see for an x is -4. And then I have 0, 1, 2, and 3. When I go to list the range, I'm looking at the y values. So that's the second half of the ordered pair. So still listing from least to greatest. So the smallest value that I see for a y is 0. And then I see 1, 3, and 4. Again, there were multiple 3s. You have a 3 here and a 3 here, but we don't repeat it. It's just a list of what is there, not how many times. So this takes us to the definition of a function. So a function by definition is a type of relation. So a relation is a big group, and then within relations, a special type of relation is a function. In a function, we are going to assign exactly one value in the range to each value in the domain. So that's a little bit confusing. So a couple other ways to think about this are listed here. So first of all, for every x, there is only one y. Or you can think of it this way, that the x coordinates cannot repeat. When you're thinking about a function, you can think about a pop machine. So when you go up to a pop machine, you have an input, which is your dollar, that's your x. And when I put in that x and choose a function, choose a button, the output is supposed to be one pop, one bottle of pop. That means that the pop machine is functioning correctly. If the pop machine gives me 2 pops, even though that's exciting, the machine is not functioning correctly. So every x value should produce exactly one y value. So if we look here at this next screen, we are looking at what is called a mapping diagram. So a mapping diagram is this that you see here, over here on the right. This is a mapping diagram, and this can sometimes be helpful to us as we try to determine if something is or is not a function. So over here on the left side, you have a listing of ordered. When we're trying to determine if a relation is or is not a function, sometimes it can be helpful to look at a mapping diagram, which is what you see over here on the right-hand side of the screen. So a mapping diagram has the domain or the x values listed in the left side box, and the range or the y values listed in the right side box. Then we see these arrows that connect the ordered pairs together. So 11 goes to -2 because over here in our listing, 11, -2 was a point. So if we look here, we know that every x has to produce exactly one y value. So each of the x values have only one arrow leaving them, which means that this is in fact a function. So this one would be a yes. If some people will look at this and think that this is an issue here, that both 11 and 13 go to the same y value. That is okay. If you think about a pop machine, you and a friend can go up and both put $1 in and each choose to get the same drink. So you both can push Mountain Dew and each of you will get one bottle of Mountain Dew. So you both put in $1 and you both got out one bottle of Mountain Dew. So if we continue on here, we have another representation here. Again, over here on the left side is your relation, and then we have this mapping diagram here. This example would not be a relation. So this one would be a no, and the reason that this one is a no is found here at -2. So when -2 produces both -1 and 1, that's a problem. So somebody went up to the pop machine, pushed a button, and they got out a Pepsi and a Dr. Pepper. That means the machine is not functioning correctly. So as we move to our next example here, we are going to work to create mapping diagrams of our own. So in your left side box, this is always where you're going to list your domain values. And in your right side box, you're going to list your range values. So we're going to list them from least to greatest, just like we did in our list. So we have -4, we have 3, we have 8, and we have 9. And then over here in our range, again, listing our y values from least to greatest, we have -2, 0, 1, 2, and 3. So we now need to draw our arrows to connect the the correct values. So 3 maps to -2, 8 maps to 1, 9 maps to 2, 3 maps to 3, and -4 maps to 0. So your answer on this one, in terms of whether it is or is not a function, would be no. And the reason that it's no is because of this 3 right here. 3 produces -2 and 3. So that is an issue. So if I move over here to this right side example, again, we need domain and range. I'm going to list my values from least to greatest. So I have 2, 5, 6, 6.5, and 7. And then over here, when I list my range values, these are my y values. I'm going to have -1, 0, 2, and 6. Again, I need to connect the values together. So 6.50 was my first point. And then I have 7, -1, 6, 2, 2, 6, and 5, -1. So since each of these values in domain have only one arrow leaving them, this one would be a yes. Sometimes we will be given a graph on the coordinate plane rather than a listing of our ordered pairs to determine if what we have is or is not a function. And when that happens, you can use the vertical line test to help you figure out if you have a function or not. What the vertical line test tells us is if we take a vertical line, remember vertical means running up and down, and go across our graph from left to right with that line, we want that line to never intersect the graph in more than one place at one time. So let's see how this works. So if I look here at this one, I'm being asked to determine whether this relation is a function, and I've been given the graph of the relation, so just these 5 ordered pairs on the coordinate plane. Because this blue vertical line hits 2 points at one time, that means that this is not a function. So my answer to this one would be no. So if I look at this left side example here, and I try to run a vertical line across here, I run into an issue right here. So this vertical line hits 3 points at one time. So that's an issue for us, which means that our answer here would be no. This is not a function. But if I run a vertical line across here, I never hit more than 1 point at one time. So this right side graph would be a yes. This is a function. So now we are being asked to use the vertical line test to determine whether or not these relations are functions, which means that first we are going to have to graph these relations on the coordinate plane. So we have a point at 4, -2, 1, 2, 0, 1, and -2, 2. So now if we try to run a vertical line across here, you will see that it does successfully only hit 1 point at a time. So for that reason, this one would be a yes, it is a function. So if I go over here to my right side example, example B, and I plot my points, so 0, 2, 1, -1, -1, 4, 0, -3, and 2, 1. So in this case, my answer would be no, because this vertical line right here is going to hit 2 points at one time. So for that reason, our answer to this one would be no. So now moving on to talking about the idea of a function rule. So a function rule is simply an equation that describes a function. So I've been using this idea the whole time of a function rule being an input and output machine. So you put in your dollar, you choose a function, you choose a pop button, and your output is one pop. So a function rule is going to be an equation that describes what we're doing. So if we look here, this that you see here would be our function rule. And it wants us to use the input values. So it gives us input values of -2, 0, and 2. So this is technically my domain. These are my x's, all of my inputs. And they want us to find the following output values. So we are going to be substituting in for x. So when I put -2 in, this is what I would have. So I have 2 times -2 squared plus 3 times -2. So every x is getting replaced by a -2 minus 10. Now, everything that you see on the right side of the equation, if you put that in exactly like you see it, your calculator can do all of that work for you. So you should try to do that now and make sure that you can successfully do it. If you can't do it now, you're not going to be able to do it on the test. So when you plug all of that in, you should produce an output value of -8. So again, make sure that you can do that. If you cannot get that correct value, then you are going to have issues on the test. So now if I look to do the same for 0, I would have y equals 2 times 0 squared plus 3 times 0 minus 10. Again, you just need to be able to successfully plug this into your calculator. So if you do that, in this case, you should find out that y equals -10. And then the last one that I need to plug in is +2. So if I plug in +2, I have 2 times 2 squared plus 3 times 2 minus 10. So if you substitute all of that into your calculator, you should get an output value of +4. So if you're struggling to do this on your calculator, please see me so that I can get you some help with that before we quiz or test. All right, so moving on to talking about the idea of function notation. So function notation is when you see what you have here, f parenthesis x. We read that as f of x, and f of x is interchangeable with y. So it's just a different way to write your output, your y variable. But you will see this often, not only in Algebra 1, but in other math classes. And it doesn't always have to be f. You could use g of x or h of x, s of x. You can use any letter to indicate a function, and x is just our most typical variable that we're substituting in for. So when we see something like this, evaluate f of x for x equals 6. When we see something like that, that means that we are trying to find the value for f of 6, which means that I'm going to replace the x on the right-hand side of the equation with 6 as well. So now, again, you can use your calculator to do this work. We are not touching the left-hand side. The left-hand side is going to stay f of 6. That's what we're evaluating. So if you evaluate this on your calculator, you should get -8, which means that an input value of 6 produces an output value of -8. If I was trying to graph this, that would be the ordered pair 6, -8. All right, so let's look at another one here. So if I'm going to evaluate g of x for x equals -4, that means that I would be trying to figure out what is the value of g of -4, which means that I'm going to replace any x in the function with -4. So again, if you put this in, what you see on the right-hand side, just like you see it, your calculator can do that work for you. If you're going to try to do it by hand, you're going to have to follow order of operations, but really you should just let your calculator do it. So if I did that, and I let my calculator do the work for me there, I'm going to produce an output of +15. All right, so we are going to stop here. You will practice with this more tomorrow in class.